So hello and welcome here on Matfyz, Faculty of Mathematics and Physics of Charles University in Prague. Welcome if you are here directly or if you are connected via Zoom. And today I would like to welcome you in this nice room or in the Zoom meeting provided by Matfyz. And today I would like to welcome you on the next series of talks in our Tech Talks for Universities, which we now organize annually every 3 years. And it is a community event organized by Matfyz and Microsoft, few guys here. And today the key topic of this series is many faces of the open source world. And I can now give a word to my co-host and also one of the speakers, Karel Zikmund from Microsoft.
All right. Thank you, Pavel. So hello, welcome everyone. Happy to see you here. We want to kind of say thank you to the volunteers. Even though we are under Microsoft, it's actually kind of punk style, not super official. And as you know, we have actually speakers from not only Microsoft, so that's a good thing. We're going to start with Anička from SUSE. We have Tomáš Herceg from RIGANTI, and then I'm going to be speaking 40 minutes each talk. With some of them, we'll have rooms for questions. We're going to actually post questions as well online, but if you're here, this is the URL that you can put there. You can put your questions, probably vote for them and whatnot, and we have a couple of folks over here to collect them. Now, I will ask you for one thing, and you're gonna be annoyed by me repeating it over and over. If you're here in person, if you're watching online, if you're watching recording, please take this QR code at the end, or maybe even during time. Thank you, I already see one phone up, love that. And fill the survey. It's part of that actually you see on the right side. It's not super difficult, super long, except one question, everything is optional, but we will really appreciate it, and it's gonna help us to improve the future events. In the past, we got actually 66% participation. So this year, or this free year, I would like to kind of raise it up, the bar to something higher. And with that, I think that we're pretty much done, and we can welcome our first speaker, Anna Marešová. So let's see. All right. Yep. Not yet.
Wow, no, it's fine. So again, good evening. My name is Anna. I work for SUSE for the last about 20 years. Currently, I'm engineering director. And SUSE is a company that's making Linux good to use for companies. Well, well, what does it mean good to use for companies? This talk will be a lot about that, so I'll talk about that later. And SUSE Labs, that's a place where we develop all the core components of the system, the Linux kernel, the essential base system, user space, well, could be cryptographic stack, compilers, Python stacks, any other languages, well, you name it, it's a lot. And it's a lot of fun because we are working with various open source communities, and we really enjoy what we are doing, so I will try to share a bit of that too with you. But first, before we start, just stop for a while and think, when did you interact with Linux for the last time? And it could be in many various ways, because Linux is basically everywhere around these days, which is something that I still find very surprising, because back then, when I started to work for SUSE, we were no way that far with it. Actually, we were still trying to find some place in the world, and now it looks like with Linux we managed to nearly conquer it. So I listed some of the places where you can meet Linux today. For me, the last time was probably when I was checking my phone, because I'm using Android. And as I was checking my phone, actually, when the phone was communicating with BTS to get some signal, it's very likely that the tower also was running Linux, because actually many of them are even running SUSE Linux. A lot of telecommunication companies work with us. And that's not only that. If you drove car, yours or your parents, then maybe your infotainment was also based on Linux. Most of them are these days. Then, of course, anytime you back up your data on clouds, well, whatever is internet is Linux. If you withdraw the money, then ATM is very likely Linux, and we can go on and on. But finally, one place where it's very unlikely to meet Linux is your laptop. And that really is a bit sad, because when we started to develop Linux, we wanted to do it in a completely different way. Yeah. So when I started to work for SUSE, the way how the communities were built were actually, we wanted to fix our own problem. And in late 90s and early 2000s, we usually have computers. It was not even laptops usually back then, that were running Windows, which were, well, not that great. So if you bought some new hardware and installed new drivers, it usually broke and it didn't even do any networking correctly. And so it was very unpleasant. And of course, when we learned that this is something that could be fixed by running Linux, then we absolutely tried to jump for it, even though it was very difficult. I don't know if you've ever tried to install Linux, any early Linux distribution. It was tough, yeah, because it didn't work with most of the hardware. And if you managed to install it, then you still had to configure it. And it involved a lot of magic. But we knew that if we get it right, it will work basically forever. So we really tried. And and this is how we built the Linux distribution together, because we just met, tried to make it work. When it didn't work, then we asked each other how to do better. There were all those Linux conventions and Linux users groups online and offline, and it was real fun. And this is how it all started. So this is what we wanted. We wanted to make Linux very nicely usable at our desktops, and we didn't really care about the rest. And of course, when we learned how to do that, we wanted to make money on that, because if you enjoy something a lot, that's what you want to do for work. And so at those 90s and early 2000s, there were a lot of Linux companies popping up, trying to figure out how to make money on something that's given for free, which sounds like a conundrum that's very difficult to solve. So what we did, one thing that's really obvious, and we did it at SUSE because actually closed source companies were doing the same things. We were selling boxes with CDs or DVDs, which even worked back then, because most of us didn't have internet connection good enough to download a good Linux full Linux distributions, which was usually something like, I don't know, 9 CDs or 2 or more DVDs with all the sources and everything, because it was not just plain operating system. With Linux distribution, you got everything that you would like to use, like Office package and image manipulation program and whatever, everything was there. And so it was really a lot. But apparently that's something that couldn't work today, because today you just download your Linux distributions. And we always knew that this is something that's gonna happen ultimately. And of course, we probably made mistake believing that we are going to win desktop users in the first place, because that never really manifested over the years. And it was kind of similar with support. We tried to use support to end users, people like you and me. So yeah, it was very difficult to install and configure Linux back then. So we thought, well, maybe if we offer some paid support, people will be willing to pay for it. At SUSE, we even tried to combine this approach. And so if you bought the box with SUSE Linux, then you would get 1 year of support for free. So you could give us a call anytime, and we would say, hello, have you tried to turn it off and on again? And well, maybe it worked, maybe it didn't, but we tried our best. But again, very unsurprisingly, meanwhile, everything appeared on the internet. You could just Google for it. You didn't really need us anymore. Now it's even more so, because if you don't know how to do something, you ask ChatGPT, and ChatGPT solves it for you. Maybe you are not crazy enough to put that on a root shell. Well, if you do, then you deserve the result anyway. But that's what we did back then, but we cannot really do that anymore. We had even more crazy ideas, like trying to bundle some proprietary software with our Linux media. For example, I remember that Linux companies worked with Corel, so you could get Corel Draw bundled with Linux, which worked. That was okay. Maybe it was even cheaper than Windows version, but the problem is that people usually cared for free software, and so they weren't that much interested about using something proprietary. I didn't want to go deep into that, but there's the whole free software philosophy that was also something that was very important for us, early Linux users, even though we originally came to it just wanting to fix some problem for ourselves. Then we still found very cool that we are allowed to fix the software, that we can tinker with it, that we can learn from it. It was not even about using it for free. It was more about being able to make it work for us how we want. Well, the last obvious option is just to get paid for developing some feature, which is something that people do even today, but it's very unreliable source of income. Why? Because, well, those customers who need to do something are not that much and far between. And also when you develop something as one-off, then it's usually very expensive. If you want to thrive as a software company, you need to develop something once and then sell it many times. So if you don't manage to do that, well, you are screwed. So that also didn't work very well. What to do with it? Do you have some ideas about what we could have done differently? How we could get out of this mess? So would you pay for support for something that's for free? And for the first brave person, I have even a prize. So what could we do? I will tell you anyway, but you can at least try to figure out something. Yeah. Yeah, that's a very good approach. That's what we are basically going to do. Yeah, so he said that we should try to help configure stuff to big companies, which is basically what we are going to do, as you will see pretty soon. So I would love to say that we figured out how to do that, how to earn the money by ourselves, but we didn't. Actually, IBM, our longtime partner, did it for us. How? Well, IBM has mainframes, those huge machines that when you are using them, you usually feel like you cannot trust computer that you cannot lift, but those are with us since 60s, I believe, and they are crazy redundant and backward compatible, and all huge banks are running that. And there is an operating system coming with that that's called ZOS, but that's very complicated, and customers actually wanted to use Linux on mainframes instead. Why? Probably mostly because it was very difficult to port any new software on ZOS, and so they just wanted to have ease of using Linux. And so IBM came with us with an idea for a product that it turned out was something that customers really wanted, and they wanted to have not only for mainframes, but for any other computer. Because, well, what they really wanted, it was not boxes, it was not products, it was nothing like that. What they really wanted was just to not having to care about that at all, yeah. Because you can download Linux, it probably will not work. You will have to figure it out. You will have to find out how to deploy it, how to maintain it. And why would you do that if you can offload this problem to someone else? So it turned out that SUSE's best customers were not end users, but usually big enterprises that were doing all kinds of things, like running Linux on mainframes in huge banks or any other institutions. And so we ended up operating not as a usual software company that's selling products, but more like insurance company. Because when we are selling support, we are not really selling fixing something, but more like promise that if it breaks, then we will come and fix it. But first of all, we will take the utmost care to make sure that it's not going to break. And so that's what we were going to do. What we found quite surprising is that customers often even didn't care about new stuff that we would develop for them. They would care more for old stuff running forever on those machines, like on those mainframes. So if we are releasing new software, we know that no one is going even to install it at all, except of testing before first service pack at least. But we also know that then they will be using it for 10 years and 12 years, and then begging for even longer and longer support, because if it works, they do not want to change it. They do not want to break it. we would offer to them migration paths to newer products, but they will not want to use it, sadly. So we know that, and we take care that it works for them basically forever. And since the computing landscape changed very much, what we are also selling is certifications, because if people want to get something done, like pass audits or get good insurance or deal with customer data or you name it, then they need to have their software certified. For example, they need to have rubber stamp to show that the cryptography in the operating system works as it's supposed to do. And how would you do that if you are a bank? Yeah, so we are very happy to pay to SUSE or someone else. There are a few more companies who figured that out, and many, many more who didn't and failed. So this is what SUSE did. And what's also very funny is that often it goes down to making sure that someone is accountable when something breaks. And I have really funny story to illustrate this. Why? Why you need to blame someone? Because then their insurance pays for it and not yours, which is helpful in the long term. So there was a bank, huge European bank, and they had new and shiny storage system, like very redundant, very expensive. And it just froze, stopped to work completely. So they were not able to process any transactions whatsoever. You can imagine how expensive that was. And so then they started to call everyone, the hardware vendors and SUSE, of course, and everyone else, so they could come and figure out what actually happened. Well, what happened was really funny. You would not probably believe it, because there were lots of interconnected optical fibers in those storage devices. And in one of those connectors, there was a very tiny piece of dust. So tiny that it didn't make the connection not work completely. It showed like the link is up, but you couldn't really push any data through it. So of course the device tried to push the data, didn't work. So all the buffers were full. And then for the next device on the line, it showed like it's okay, but it couldn't really push any data. And this way, all the buffers of the system failed, and well, it froze. So I'm not sure who paid for it, but I'm sure they took a lot of time trying to blame it on someone else. So yeah, that's how it works. And now when I spill the beans, you might think that it's easy. You just take Linux, put together some people who can understand it a bit and support it and make a lot of money, yeah? So I might probably disappoint you. It's not that easy. There are many companies who tried it and still try it. Like, feel like we hire a lot of nice young students, for example, who are not working for that much, but they are really very clever and they will learn very quickly. And so when customers come with their problems, we just throw it on them and they will fix it, and on and on. It doesn't work like that, sadly. And many companies learn this hard way, that when you are not very sure what you are doing, ultimately you will get lost in all those pages. We had even one very huge customer who tried this approach and failed desperately. It's a big technological company that's making specialized hardware. They need operating system for that. And once they figured out that they do not need to pay us for operating system, they can do it by themselves. 2 years, and they came begging that we should take over again and fix it for them, because they were completely lost in all those patches that they had to put in the system. Because if you want to maintain some particular version of, I don't know, Linux kernel, for example, and you want to change it, and not to change it too much, but still fix all the security issues, then you end up with thousands of patches in a few years. And so that's something they couldn't really deal with. So how do we do that? Well, actually, it's pretty simple. We don't have generalists, we have experts. We have people that cover all the ecosystem, all pieces, all parts of kernel, all pieces of packages, everything. And they understand really well what's going on in there. They are paid to spend some time working with upstream communities on active development of those things. So then when bugs come, then understand the system inside out, and they know very well how to fix it so that it works forever. And also usually they push their fixes to upstream, so then it's fixed for everyone and forever, which helps a lot. So that's what we do, but if you wanted to do that, you would have to find a lot of people understanding a lot of stuff, and I guess you would need about a few hundreds of them, which is not very useful for a startup, to be honest. Yeah, and I promised some funny bugs because bugs, that's what we are fixing. Unfortunately, most of the bugs are pretty boring. So this one is a bit least boring, but it's also very old, but it's probably the most, let's say, amusing bug that I encountered in my career. And it happened in June 2012. Here it was around midnight. In Asia, it was morning. In Australia, it was noon, very busy time at airports, actually. And unfortunately, at that very moment, a lot of Linux systems in the world just froze. SUSE Linux being only part of that, but quite a huge one. So for example, in those Australian airports, there were no departures at all possible because the company that was processing boarding data of passengers had everything completely frozen. And it took about an hour to make it work again. So what happens? Well, the thing is actually the Earth is to blame for it in this moment. Because how do we define the day? It's usually pretty straightforward. The Earth rotates and that's a day. But unfortunately, since we started to measure time very precisely with atomic clock, then we learned that this rotation doesn't happen in uniform way. And so the difference between this, let's say, astronomical time measured by Earth and the atomic time, UTC, measured by the atomic clocks, gets different over time. And so scientists wanted to make sure that this is kept in sync. And the mechanism for that is that every once in a while, when it's needed, you can insert, or actually even remove, but I believe that it never happened. You usually only insert something that's called leap second. It happens either end of June or end of December, and you just add 1 more second to make that even again. So how it happens technically, you probably know NTP protocol that's used to synchronize time on your devices with the network. And so that system is hierarchical. And the first layer of servers is connected directly to the atomic clock, and then it goes down. Your device would usually speak to layer 3 or 4, something like that. And on the day when the leap second should happen, this is how the information gets spread. There are 2 bits that you read and check that today is the day, and then it's up to operating system to deal with it anyhow. So some operating systems just ignore that because why not? It's only 1 second, who cares anyway. Some of them very, very slowly try to add up a tiny bit of time to stretch it so that at the end, it's exactly where it should be. Most of the operating systems just add a second to the end, like you hit midnight, then after 1 more second, you go back again, hit midnight, and it's done, which usually works pretty well, but sometimes not so much. So again, please, what do you think that can happen? Again, I have 1 more plushie for first person, brave enough to speak. Don't be afraid, because a lot of things can happen, yeah, depending on what's going on with the OS. Yeah. Hey, yeah, that can happen, for example, in this case, indeed. Sorry, I'm sorry. I apparently suck at drawing. Yeah, actually, anything else could probably happen too, even though the very last option is very unlikely. You would have to do something really crazy for that to happen, probably. I don't know, using a time of the day in a while loop. Had very broken NTP, then maybe it would happen, but then you would totally deserve it anyway. So what happened with our kernel? So yeah, there was a bug introduced sometimes between the last 2 leap seconds that made all the kernel timers behave a bit differently than before. So what happens in operating system all the time? Usually there are a lot of threads and process, and they are mostly waiting for something. That's what you usually do when you are a process. You are waiting for another thread or process to finish, or you are waiting for some timer. And there's lots of such things at once. And usually those timers are very, very short. Like you check very often whether something is ready or not. And well, if you do something as funny as going back to second, what happened in this case is that we just removed 1 second from all those timers. So especially all the timers that were shorter than 1 second just fired all together. And so a lot of crazy things happened at the time, and the systems got completely overloaded. So actually, it would help just to reboot. It would be fine. But of course, it took a while before we figured out what's going on. So that's why the delay was a bit longer than duration of one reboot. Well, that's how it went in Australia. We had much more customers than that. One of them was a jockey club in Hong Kong. And at that very day, it was really interesting. They were running the most important race they had in a year. So horses were running, people were betting. But you know what? This jockey club is very, very affluent organization because they own some most expensive properties that are available in the world. And so also their hardware was the best possible hardware, the most redundant hardware you can get. And so guess what? Nothing really happened. And it was so crazy redundant that just the load was a little bit higher, but it pushed through and horses could race without any issues. So that I found really interesting. Yeah, so I spoke about fixing bugs, but it probably makes sense to stop a bit and speak about what's the environment where we are fixing the bugs. Because your average Linux distribution is huge. I actually did a calculation by myself for our SUSE Linux Enterprise Server 15 series, and there all the code base had more than 1 billion of lines, which is pretty insane, to be honest, especially given that we are just hundreds of people maintaining all this. But that just shows how efficient it's to work with open source. Because if we wanted to do this by ourselves as one company without open source community, I believe we would need, someone did that calculation like 1,000 or maybe even 10,000 more people to deal with it. So yeah, that's what we work with. And unfortunately, over the time, we added a lot of things and everything depends on everything. And people want to make sure that nothing ever breaks. And so basically, whenever you add something to the Linux distribution, be it new package or some dependencies between the packages, you need to cope with the fact that it's forever. Even if you fix the kernel, you need to make sure that the binary drivers custom built by your customers are still going to work even in that fixed kernel. So it's actually, we spent most of effort on making sure that this somehow holds together. And it's getting colder and colder and more difficult, but even though we have some efforts on making things shrink a bit again, it's tough. But fortunately, we do not need to care that much about the present. Like we need to care very much about the past, but present and future, that's something that the community does for us. And how that works? Well, it's pretty simple. So if you develop something new, you could either keep it forever and maintain it, we call it downstream, like apart from the upstream open source packages. But then you would have to make sure that it never breaks when you upstream this package comes. You would always have to port it to the new version. Or you can just push it upstream, persuade the open source maintainers that what you did is a great idea and they should want to adopt that. And then it's not your problem anymore because all this will happen for free for you. And it will be someone else's problem to make sure that when they develop some new feature, they are not going to break your code because that was their first, right? And so that's why we are working with open source, because it's very efficient. Okay. Now I have one more tiny prize. That's SUSE towel for some hitchhiker who would tell me whether they ever contributed to any open source project. Yeah. Oh, wow.
That doesn't use like discrete steps, but it's like a little linear, which like they didn't have until like last year.
That's cool. Well deserved then. You have a proper Linux hacker. Ah, I tried. Okay, so what I wanted to show is how it looks in practice. And I picked one feature that we developed and slowly are moving upstream together right now. and that's full disk encryption. So until recently, if you wanted to encrypt your disks on Linux, it was quite difficult because you had to enter your passphrase once for bootloader, then there was no secure way how to move it to kernel, so you needed to enter it again, and it was quite painful. Meanwhile, most of our customers, like corporates, were not using anything like that because they were usually relying on VMware, and they have very nice solution that works so that all the encryption happens on hypervisor and all the keys are shared over the network. It's all very nice and comfy because the operating system doesn't need to know anything about it whatsoever. And they would probably use it forever, but unfortunately for them, maybe fortunately for us, the prices of VMware are going very, very high and even higher. And so they are asking for something else. And fortunately, now we can help them because meanwhile, the TPM chips got into Linux, into machines that are then used, and our customers are running Linux on it. So it's actually pretty easy to implement it now. So what TPM does, it does many cool things, but what it can do, it can store your key and it can decrypt your drive if it measures that your operating system is fine, that no one tampered with it. So it stores some information about how hashes of bootloader and initrd and kernel should look like, and well, easy. But what is not so easy is how to integrate it into the Linux distributions, how to make all the tools that are used with the Linux distributions work with it. Especially if you want to update your distro, then you need to figure out how to do that, because as long as you install any security update, and of course the kernel hash would change, and you need to find a way how to share this information with TPM. And there are many ways how to do that, but the thing is, if we did it without thinking twice, without working with community, we would be bound to maintain something that would be going through all the distribution like forever. So we didn't do that. Instead, we spent a lot of time working with upstream, in this case, mostly with systemd developers, persuading them that our solution is the best one, and we are slowly upstreaming it, and it looks like that it will work out. And when it's done, we will be able to forget about it. All the Linux distros will use our approach, and we will not have to take care of it. So that's how it works in practice then. Okay, and I have no more swag, but still I would like to ask you if you feel like to answer, what do you think will be our biggest challenge? Because you've heard a lot about how it was in the past, how it is now. So what's coming next?
I think it's going to be pesky time again, because the end of the Unix epoch is in 2038. And so that will be, for any kind of Linux system that's currently running, that will kind of mess up their file systems and stuff. So that's my thing, but like, that's the biggest challenge.
Yeah, that's spot on. For example, at SUSE now, that our current line, SLE 15, will not be possible to support in 2038. We are making sure that it's all fixed for the next line. So let's just hope that everyone will migrate by then. But they probably will not, because they usually don't. Okay, thanks. I also believe that we will probably have a lot of fun with security. I don't know if you noticed what happened last year with very tiny, unimportant project called XZ that's used by everything. If you know that XKCD joke, it's exactly such project. When someone just sniped themselves and persuaded its burnt out maintainer that they will do better, and built trust very slowly, and then put in very nasty backdoor that was very difficult to find, and only thanks to some Microsoft guy who was tinkering with the software long enough to figure out that it's somehow fishy. So he found the backdoor in that, and it was really a nasty piece of work. And I'm quite sure that we will see much more of that, because the world is getting a bit crazy like now, and apparently a lot of countries are working against each other. At SUSE, we are global, and we are always joking who could be agent of each country. That's really funny. It's kind of inside joke for evenings and pop. Yeah, but this is actually the last line. I just wanted to say that when I was studying here at this lovely school, which I'm actually very happy that I can be back here. I really enjoyed it a lot, so thanks for inviting me. So back then, working on operating systems was really cool, something that mostly everyone wanted to do. Today, it's probably not the case anymore, but yeah, I came to persuade you that it's still cool. That's lovely career, actually kind of easy career, because people who can deal with Linux are always needed. And even though now Linux is a bit boring, it's just there like a washing machine. Yes, it still needs to be developed. And because it's developed in the open, it's very nice and easy to find a new job, because you just point to your GitHub and that's all the reference you need. You find a friend at the open source conference with in that company where you would like to work, and it's all done. So that's something I would love you to consider. Also at SUSE, we are running student stages, so programs for interns. So if you ever want to do something funny, you can always check our job website and perhaps you will find something open. So thank you. And now you can ask me any questions if you want.
Any questions, Poranička, from over here or online? Nothing online. Before you brave up and either post it online or raise your hand over here, that funny QR code over there in the bottom right corner, guess what it is? That's our survey I already talked about before. And it's going to be on the next slide as well. So do we have a brave person to ask a question here? All right, let's start swapping the speakers. You can still ask the question. Tomáš, can you please come? Thank you very much, Anička. And in a minute, we're gonna have our next speaker, Tomáš Herceg, about his slightly different open source path from a smaller company, much smaller than SUSE or Microsoft, at least now. All right.
One, two, three. Okay, it seems it's working. Great. Awesome. Okay, so hello everyone. My name is Thomas. Right now I'm one of the slides probably is missing, but never mind. I'm running a small software company here in Prague, and we have also an office in Brno. I started the company 14 years ago, which corresponds to the time when I left this school prematurely. I didn't finish. I wanted to do something practical. So I thought that if I start a company who would do like software development and making applications, then as a CEO, I will have a lot of time to write code. Actually, it didn't work out very well. So I'm like more working with emails or Teams or Zoom and these things, but still I'm overseeing a lot of projects happening in my company. So that's also kind of fun. I would like to speak about .vvm, which is an open source project I have started in 2014. It has way less contributors than any Linux distribution, I guess. Like at the best times, we had a team about of 10 people working on the project. Now we are like 3 or 4, depends on like how much, and nobody is working on that full time. On the other hand, the framework somehow like does what we wanted to do, so it doesn't require that much effort. Of course, there are always some bugs. We also have some very nice date-related bugs, but it's not that much, so we don't need to work on it full time. The framework, it's my background is I was always using C# and .NET, so I'm running on Windows, these things, but I always liked open source, and this framework actually made it to become a member of the .NET Foundation. It's an organization that helps about 500 .NET open source projects, and several times we were there. Every month they publish a list of most active projects, so several times we were in top 10 most active projects based on a number of commits. because we were fixing our like CI/CD pipelines, which means that you edit one file like many times. So probably that was counted in the statistics. However, the project is on GitHub, and let me tell you something about that. Who of you, can you raise your hand if you have been building web applications, like something for web? Okay, so like 1/2 of people. Okay, great. So probably you have noticed that it's a bit hard because the code, which is your application, it's split between the server and client. So something is running on the server and some code probably runs in the browser, and they need to somehow communicate, and you have probably been building some APIs and making sure that what you send on one end will somehow end up on the other end. And there is also a lot of data-related issues that may happen on the way. There are also connectivity issues, so you can never be sure that the information reaches the other end. You have to have some like resilience and these things. And we started this framework in 2014. And of course, if you would want to do something with the web browser, you need to use JavaScript, or at that time you needed to use JavaScript. And if you tried that in 2014, it wasn't that a nice experience because the language didn't have all the features it has today. Still, my favorite language is C#, but when I look at what JavaScript can do today, it's pretty impressive. But a lot of things were added after 2015. So every year there is a new standard. They are adding more and more nice features. I want some of them in C# actually, still not there. But in 2014, there wasn't enough tools. There wasn't very good debuggers for JavaScript code, which you currently have in browsers. So that level of comfort when you are writing code, it wasn't there. Today, if you want to have the client-side code, you can use .NET for that because browsers support WebAssembly, and you can compile .NET to run in WebAssembly. But again, this wasn't available in 2014. And basically, this framework we built, I built with a couple of people from Matfyz. Then, like, this framework allows you to build web applications without learning JavaScript. That's the biggest benefit, because it's not about learning a language. It's pretty simple, but you need to learn all the libraries, all the tooling, and all the best practices, because if you would write JavaScript code the same way you write C# code, probably there are not, it's not the same, even though there are classes in both languages, they behave quite differently. Yeah. So this framework basically helps you to get rid of APIs. It generates the communication layer between the server and client for you. And that was the funny part of writing that, because like, who wants to write thousands of lines of boring code when you can write 10,000 lines of like very complex, very interesting, very nice code, challenging one. Yeah, and it offers a declarative way of defining user interface, because we use some model view model design pattern that was already used in other applications. If you have been using, for example, WPF or Xamarin.NET MAUI, you can use MVVM there also. The syntax of this framework, we implemented our own view engine. So basically we had to write an HTML parser and add these syntax extensions into that. So it supports our custom elements. It supports like these data binding expressions. And they are basically translated to JavaScript. So you can just write this HTML syntax and have a C# view model behind this page. And the framework will somehow generate the client-side part for you. And if you look at this example, basically the view model is trying to like handle the state of the user interface. So everything that is going on in the UI needs to be represented in this view model. So there is a list of tasks. This sample is a simple like to-do list. And then there is a field for entering a new task, which you can put there. And there is an add task function, which will just take the new task and add it to the list. And the user interface somehow like reacts to these changes of this object that lives on the background. So if there is something in the collection, it will render these HTML elements with the individual tasks. And there are some expressions, like, for example, is there the laser? Yeah, here. Yeah, so like, for example, this visible, it will translate to some part of JavaScript code. So once this expression is true, this emoji will be visible. Otherwise, it will disappear. So it's doing just some JavaScript CSS magic that will dynamically update the user interface. Yeah, so that's, we had to write parser for this syntax, cover it with tests. We had to write a code that serializes this object, send it to the browser. So this view model can then live as a JavaScript object in the browser and guide what's going on in the page. Yeah, so like there is quite a lot of interesting things behind that. And why we did that, we tried to use some proper JavaScript framework at that time, but in 2014, as I said, it wasn't that comfortable experience. There was Angular.js. It's different than today's Angular. It was the first version that is not compatible with the current version of Angular. There was also React, and there was Knockout.js, which isn't very much used today, but we chose this one because we couldn't tell the future. We didn't have the crystal ball. So still we are using that. It works. It's a very nice, very small library, and we never found a bug in it in 10 years. So I think it's a pretty good score. One of the benefits why we did that is that view models are testable. So you can pretty easily cover this logic of the application by some tests, which is great if the page is doing something complicated, like load data from database and do some like manipulation with that. You can quite easily test it. And also, one of the benefits why people and companies use this framework, because it's hard to know .NET and also JavaScript well. Like, it's not about learning the language. Learning the language, as I said, it's quite simple. But to learn all the ecosystem, the practices, get experience with that, it's not that easy. If you choose another language, such as JavaScript, then it's easier because you can use JavaScript on the client and on the server at the same time. And today, Microsoft has a framework called Blazor, which is using the WebAssembly. So you can write both parts, the client and the server, in C#, and it will also work. But we choose a combination of two languages, but you don't have to learn one of them. Yeah. And we added, because the framework is used in my company for creating applications for our customers. So of course we put there a lot of components that made our life easier. So there are like very high level components for like rendering tables based on what you find in the database, doing filtering and these simple data operations. It didn't start as an open source project, to be honest. I wrote the first prototype of that and I wanted to show off in front of my colleagues. So first I wanted to like zip the source code and send it by email to someone. Then I said, oh my God, this is a stupid way. Let's push it on GitHub and we will see. Like, and then I could send them a link, so it was great. But then somebody sent me a PR, pull request. So, and it was a very meaningful pull request, and the guy is still working on the framework today. So like more than 10 years of cooperation. That was great. And because I saw that some people at least gave us feedback to this code, then I said, okay, maybe it's not just my crazy, stupid idea. Maybe it would be useful to someone. So I never believed in that I would create something that would be that great. So I had to test it on several bigger projects within my company first before I was willing to speak about that publicly. But like when I proved that it helps and it delivers some value, then I decided to hire several people just to work on the framework, and we were then using it in our company. And because, of course, people need to get paid for their job, so I was investing my own money in the first versions of the framework. But to make it at least a bit sustainable, we started building like commercial extensions to the framework. So the framework itself, with a basic set of components, is open source. It's on GitHub. Anyone can use it. And if you want to build like really large web application using this framework, you can purchase commercial add-ons, but nobody forces you to do that. I think this is the honest way of making sure it's available for everyone, even if you want to just try it. And also, one of the commercial extensions is an extension for Visual Studio, which will give you like auto-completion and like more features. So it doesn't add the features of the framework, but it makes you more productive when you are using that. So like that's how we try to do that. It's very difficult anyway. Like I think that making money on open source is the second hardest problem in IT. The first one would be naming things. So I think that this is very difficult. And we have seen in the recent years a couple of .NET open source dramas, because there were authors of popular .NET open source projects, and they decided to make it paid. And one of the libraries tried to do it in a bit dishonest way, because they added something that triggered during the build of your application, and it tried to extract your identity from Git repo, from the Git configuration, and send it somewhere to just like track who is using this project. But like it's violation of GDPR and like a lot of things. So that made, I think we lost a lot of trust in the .NET at all for open source. And there was other libraries who just published a new version and changed the license. But like when you are upgrading a library from version 3 to 4, you don't expect that its license would change. So like it's also not very clear, very transparent way of doing that. So I'm quite happy that we had this thing with the commercial add-on. So the framework is free and it will be forever free, and you can do whatever you want with that. And if you want to support us, and actually most of our companies, most of our customers are paying for these commercial extensions, that helps us to be sustainable. Still, it's not that much profitable. It covers what we put in the development, but like I never made anything directly on that. But on the other hand, because we are making this open source framework, it was very easy for my company to hire new developers, because some people think that we are doing cool things and they want to be part of that. And also it helped us to get some projects, some customers who needed some help, and they trusted us because they saw what we are doing on GitHub. So that can be beneficial for the company, but it will not necessarily be visible on your bank account. Yeah. So it's like that. In 2016, Microsoft introduced Blazor, a framework that is trying to achieve a similar goal, like allow you to build web applications without learning JavaScript, just with C# and HTML. They are using other methods. They are using this WebAssembly. I'm biased, so I will not be talking about that. There is one drawback, that the runtime in WebAssembly is slightly bigger than our like 100 kilobytes of JavaScript code. That is all our framework needs to download. On the other hand, it's an official solution from Microsoft. A big company is standing behind that. So like it's, for a lot of people, it's probably more like trustworthy than some anonymous Czech-based small company of like 40 passionate people. On the other hand, our company, we were already using .vvm on many projects, so it's not that easy to switch to something else. And also, any library that is new, it takes some time until it implements the crucial features you will need in big projects. So like anyone who started using Blazor in 2016, probably you have to wait 2-3 years for 2-3 versions until there is enough things that you will not be blocked by something missing. So like we are still using it today, and we are still investing in that, because we have a few hundreds of companies using this framework, and they still like it. They still start new projects with .vvm. Writing or doing open source is not only about writing the code of the framework. There's a lot of activities, and unfortunately, these activities can take even more time than the open source project itself. Yeah, so it's fun to write like parsers and these things in the framework, but we need to cover it by tests, and by tests I mean by a lot of tests, because any change in the framework could break potentially not just one application, but like thousands of applications, and you don't want your bugs to return. So we have a lot of policies like find a bug, write a test. We have to do it like that. There are all kinds of tests that you can imagine, from simple unit tests. There is a lot of quite complex integration tests, because this framework is running on server and on the client. So we have to test the communication between. So like we are basically, sometimes we are simulating the HTTP traffic, building the requests, parsing responses, and making sure it works the correct way. Then we had to make really end-to-end testing. So we have Docker containers which physically run a browser window and interact with the page, look if it contains the correct elements that should be there. They're clicking on things, downloading, uploading files. We spent hundreds of hours to make this work, and it's never 100% reliable, because like sometimes they publish a new update of the browser and it starts behaving a bit differently. So like when 98% of tests passes, it means that like probably it's right. You just need to manually verify the tests that fail, try to run it on your own machine, and usually you will find that they still work. Just there was some hiccup. We run every test 3 times, and sometimes it fails 3 times in a row, but still like it's the problem of the test, not the code. Yeah, so like you have to work in this non-100% exact reliable environment. We were using a lot of continuous integration tools. We started with TeamCity, then migrated to Azure DevOps or Visual Studio Team Services, or what's the name of this service this week? I don't know. Now we are using GitHub Actions. It's working quite well, but sometimes they also broke us, and also it was somehow related to date and time. If you are formatting date for like English, so you have some date and you want to write it in English format. In some update of operating system, they changed that, instead of putting space between the date and time, it's putting non-break space in that. So if you are just like comparing 2 strings, it will fail. So we had to implement like various heuristics. It's only on some, like probably only on some distributions of Linux, it's happening based on some like native libraries that are present there. So it's very nice. We had another date-related bug in, did you know that here in this time zone in 1891, there was like 3 minutes missing on one day? It's like 1891, so it's pretty long time ago. Austro-Hungarian railways decided to switch their time from Vienna time to Prague time, and difference is 3 minutes. So if you look what is the time zone offset in 1891, it's 57 minutes compared to UTC. Amazing, amazing. We had some test which was generating random values and trying to serialize it and deserialize it back, and it was differing by 3 minutes. Oh my God, why? So we used binary search to find the exact date. The exact date is 1st October 1891. Amazing thing. Yeah. So you like, you want to do these things. It's always DNS or date. We are doing code reviews. Every pull request, everything that gets merged to the main branch has to go at least through 2 people. We are a small project, so we can have this process like that, because the total team is like 4 people. So at least half of the team needs to see it, so it can go to production. And of course, all tests must pass. We have a lot of discussions when we are implementing some bigger features to the framework. Sometimes it can take a couple of months until it's really well tested, merged. We always try to dog food it on our projects in my company. So sometimes we have to wait quite a long time for the feature. A lot of discussion is about conflicting features, because you want to add one feature to the framework, then you want to add another feature, and like they somehow don't work very well together. So like we redesigned a lot of things. We were almost ready to merge it, and then we found, oh, okay, we cannot do that because that would be conflicting with something else which may not be also implemented. So it's very, very, very funny. We had to establish some release process. So like we are publishing internal previews, public previews, and there is a lot of packages you have to publish at the same time. Yeah, so it's you have to have scripts for a lot of things, because otherwise you would, and there are various dependencies between multiple repositories. So it's also quite funny. .NET Foundation helps us with signing the code. Packages which you publish to NuGet needs to be signed. So they are providing us infrastructure, so we don't have to deal with code signing certificates, which currently they have to live on hardware tokens. So it's not that easy to do it on your computer, especially if you want this process to be automated. We have to do the documentation. Maybe AI will help us someday with that, but currently we are doing it by hand. Whenever I'm flying somewhere and I'm offline for a couple of hours, I am filling the documentation, because that's the only meaningful thing I'm able to do on the plane. It's also a task for itself, because you have quite a lot of documents and you want to be consistent between all of those. So like maintaining documentation, it's not that easy also. There is a lot of sample repositories, so it's not only one repo you have to take care of. We have dozens of others, smaller repos. When we publish a new version, we should upgrade these things. We are using Dependabot, which is an extension for GitHub that scanning your repos, and if it sees that some libraries can be updated, it will make automatically a pull request that tries to like update these. And if you have continuous integration, then probably you will see that, okay, it's still tests can still pass, so it will probably be good to go. It can save a lot of time, but you need tests and automated pipelines. Another interesting challenge is to build an extension for Visual Studio, or now we are also working for support of other development environments like VS Code or JetBrains Rider. It's because we have our own custom syntax based on HTML. We have to implement our own like syntax highlighting, and also like we want to make auto-completion, and we want to make it clever. So it would really like suggest you're writing piece of C# expression in this HTML language. So we want to like semantically understand the expression and offer you the valid choices for that. Of course, first we did a naive implementation. So whenever the file changed, like we parsed the entire file and like did these things. Then we found out, okay, but when people use it on real projects, their like pages have like thousands of lines of code. So you cannot parse everything on every keystroke. You would have to wait for the result. So like when you are looking at the code editor, behind that we have a semantic tree that represents the entire document, including all the white spaces and things. And when you are typing in the editor, we are just updating this tree on the background. There are some occasions where we have to rebuild either the entire tree or part of the tree. We are doing some things asynchronously, because like you need to load some reflection metadata to understand what this component can do, what type it represents, and these things, and it takes time. So we are doing this on a background thread, not to slow down the typing. So it's a lot of interesting challenges, a lot of race conditions. Sometimes you try to fix a race condition, so you will introduce a deadlock instead. So it's a very, very funny, very, very nice activity doing that. It's also a bit reverse engineering, because we are trying to extend parts of Visual Studio which were never designed to be extended. So like if you want to know how you can like implement a class that is marked as internal, like there is a way how to do that, but not a very nice way. So like it's sometimes it's a bit detective work. And I think that this was the best experience I had when a lot of things I liked in my career Most of them were related with this and other open source projects. This is not the only open source project into which I'm contributing. So like we are doing a weekend hackathons to work together on some new features. It's quite fun. Also, if you are thinking about helping some open source project, it doesn't have to be some hardcore work in the core framework or core of the library. You can help by like writing sample applications or making videos about that, writing blog posts, or for example, speaking at conferences about how is your experience with using some library. All these activities can help the authors of open source projects, because like when you invest your time in making open source project, you want people to use it. And doing marketing for open source project, it's also a very difficult task, and you don't have time for that. Maybe you don't even want to do that because you want to write code. And like speaking about that, promoting this framework, telling people about that, it also consumes quite a lot of effort. And whenever we are hiring people and I see their GitHub profile and I see that the GitHub wall is at least a bit green, I'm looking at their contributions. It's also very useful, because like if your work speaks for you, it's much better than what you just write in your resume. And it's also an opportunity to meet people from the like community or the ecosystem which you are a part of. So if you are using .NET, you can meet other .NET community members on conferences or other events. And I guess the same things is valid for any other language or technology. So that's it, a few links. And if you have any questions about like why we did that and or anything else, just like I'm here. So feel free to ask anything. And of course, give us feedback.
Right, thank you very much, Tomáš. And, we have a question over there.
Okay, so let me read it. Do you think it makes sense to promote your open source projects to attract attention and contributions to it, or should the project find its audience naturally?
I think that you should promote it, because there is so many projects, so many things that are now competing for anybody's attention that it's very hard to find something just because it's good. You have to tell people about that. And I always had a problem with that, because it seems like boasting, like I did something and it's very cool and I don't want to tell people that it's very cool. But like sometimes you have to, otherwise you would be spending a lot of time, and it's not that rewarding if nobody knows about what you are doing. So it's about finding a good compromise. Like today, if you open LinkedIn, maybe you will see a lot of people who are just seeking for attention. And if you look what they are really doing, it's nothing that special. But so that's the other extreme. So I think you have to find some compromise, like talk about what you are doing, maybe not push it that hard, but like don't be ashamed that you are doing, that they are trying to do something interesting. Just tell to people.
Okay, thank you very much. Some more questions here in the room or virtually at the AKA MS/TechTalksQA. Okay, there's one question.
Hello. How do you debug as a code running in a browser?
Sorry?
How do you debug a JavaScript code in a browser that you generate?
There is normally you can open the DevTools and set the breakpoint in the debugger. It's the code, like you can debug the framework code. You probably don't want to do that if you don't understand what's going on inside. But basically that's our job. Like the job of users of this framework is not to debug this code. So like there will not be that many situations where you have to do that. Typically, we do that only if we are hunting bug in the framework. But if you are using the framework, you will probably not need to do that, because either the code will not even generate some JavaScript because that's something the framework doesn't support, so it will fail on the server side. And if it goes to the client side, usually it doesn't crash there.
Okay, thanks.
So you made it easy for everyone to not debug JavaScript. Awesome, I love it.
Some more questions? Let me check the online form, but nothing there. So if there are no more questions.
So I would like to thank Tomáš for a very nice talk. And our final speaker, Karel from Microsoft, he already partially introduced himself. So Karel, you have word.
All right. So again, reminder that we have the survey. We will be very happy to, if you rate the talks, tell us what you think about the event and whatnot, no matter if you're watching recording, watching live, or here in the room, obviously. All right, so let's get in. First, something about me. I'm usually gonna open everything. So I worked for quite some time on .NET team in Microsoft, almost 20 years. I started as a developer, so worked on kind of subsystems like the metadata type system and that stuff. You will hear stories about that. Lately, last 5 years roughly, I'm actually maybe 7. I'm manager of the .NET networking team. You're gonna hear some story from that as well. Actually, after saying that this is like, open source event, I realized that what I'm going to talk about, the most interesting things are mostly from the closed source .NET framework, but .NET itself is open source as well. That's the .NET Core. Things over there are actually much nicer, much easier, because we kind of shrunk everything to make it maintainable. Yeah, so the most interesting and horror stories actually from the closed source, but it's related to the open source in general. And obviously, it's not about knowledge of .NET, as Tomáš said it in his talk, and Anička, right? All these stories or things they apply actually to many other typical, other frameworks, languages, whatnot. So if you're working in C++, Rust, Java, TypeScript, Go, whatever, you're gonna see very similar problems in those places as well. All right. So besides obviously working for .NET Framework, I'm organizing these things, help we're doing Matematicko-fyzikální and that stuff as well. If you're interested in that, ping me on LinkedIn, Blue Sky, whatever, on my website, where actually this event is published. There's lots of contacts, so there's a way how to get to me. Anyway, moving on, I'm gonna start with my first serious investigation, which actually dates to 2005. So quite some time ago, actually 2006. So it was like 3 months into that. And it was interesting that we saw failures. Let me actually restart the counter over here. We saw failures from build lab of Windows. So Windows had really huge build labs, and it was not for the whole Windows, but it was only like, one large organization of a couple of hundred people. They had like, I don't know, maybe 100, maybe 200 machines. I don't know, I didn't count. And that build lab basically built just that part of the Windows on and on, usually twice per day, because they couldn't do it faster, because it's a large piece, right? Like Anička said that OpenSUSE or SUSE is actually 1 billion lines of code. Like it takes a while to compile that, even part of that. And it was interesting that in one of the build lab, once per week, they got a access violation dialog. So it was in 2005. CI was not not called CI. It was something like CI, but not quite that. And obviously the dialog kind of popped up, and then you had to come, click OK. So what happens to the build machine? It hangs. Not fun, right? What was interesting that at that time, what happened that they updated the toolset to 2.0, .NET Framework 2.0. So this is not .NET Core. This is a long time ago. .NET Core didn't exist back then. And toolset is basically set of your compilers, runtimes, and things. The stuff that you use to build your product. You want it frozen. Because if you want to rebuild it again on another machine, you don't want different result because you have another glibc or GCC compiler or something installed. In our case, obviously, something different. Back then, it was not on Linux. But you want it frozen in the time. And what happened, actually, we updated the toolset of the .NET Framework itself to 2.0, like RTM, as a ready manufacturing, so the last version. And suddenly it started failing. So obviously, who do you blame? We changed only the toolset. It was only .NET That's your fault, right? So that's how it ended up on our plate. Once per week failure, like it's not quite too much. Anyway, they got a repro, so they could build just like a couple of files or a project. They ran it in a line, and it kind of failed once in 50 runs. So that was actually already good. That's decent. You can work with that, right? It's not always. That would be much better. They can get it under debugger. But at least in a while, when you have a repro, and by repro I mean a reliable way to get to the failure, it's something. So that was something that we could take. And it was interesting. I actually looked up when I prepared this talk some couple of years ago, I looked up the old emails, and it was interesting that there was this interesting sentence in the email, like, oh, it looks just some boilerplate stack checking code. Which actually, if you look at it at the lens of today, that just screams, oh my gosh, this is a huge problem, because I see Anička already smiling and laughing at me. You know, this means stack corruption. Stack corruption means that you're basically under attack or something, code overrun, like security folks are going crazy and whatnot. So that was a big deal, but it was like email, like, yeah, it looks like some boiler check, you know, just check it out, right? So it was another interesting thing in like, oh, Karel is relatively new. I was in Microsoft 3 months, so I knew everything about the code base, obviously, and I'm very sarcastic at this moment. So it might take some time. It took roughly a week. So this is the only call stack you're gonna see today. And over here, you can see what was on the call stack. So at the bottom, that's CSC, which is C# compiler. That's actually, if you're done, do something in .NET, it's not the Roslyn, the compiler written in C# itself. This one was written in C++. And it works into the runtime. That's the thing at the top, the MS Core Works, workstation, because we had the server version and workstation version because of GC, different GCs. And that calls in dredge meta, which is metadata, define parameter, and you can see some destructor if you love and know C++. And over there, unlock read on some UTSEM, so semaphore, suddenly it kind of, popped. So the question was like, who corrupts a stack like that in a destructor, right? You're unwinding the function, the destructor is running, what the heck? So the one magic of things in runtimes like Java, .NET, and whatnot is GC, garbage collector. Garbage collector runs around, changes things, and obviously people don't understand it, or back then they didn't understand it, they still don't understand it, but they trust it more. Back then they didn't even trust it. So GC probably is the fault here. Now, well, if you remember the call stack, it was all in C++. So even though we were compiling for .NET, we were not compiling running .NET. So there's no way how GC would be running. So it was like, no, that's not the reason. But it was interesting, that was the first thing people jump. They see some magic, they know about some magic, it must be the magic fault. Well, if the magic is not running, it's hard to blame it. Well, they still do blame it, but usually they are not right. So what was interesting that when I looked at the dumps and whatnot, that there was like changed value between caller and callee. So one function calls another, right? You look at like what's on the stack, you look, dig it out, you spend some lovely time with assembler, and you see that one value is different in the caller, and the callee gets different value. And you notice the difference is only 1 bit. It's like, okay, that's suspicious. Who changes bits? Well, typically it's GC card table. Back then, GC card table is a thing where basically GC is optimized, and it says like, oh, somebody wrote in this piece of memory, so I'm gonna make it dirty, and therefore I have to rescan it later when I do the GC. So kind of like nice, cool things. Well, again, magical things, and honestly, back then, the GC card table actually in .NET here and there corrupted bits here and there. Well, it's not GC card table because, as I said, GC is not running. But it was another interesting thing to see that even, not myself, I was like fresh 3 months on the job, but even kind of some old timers on the team like, oh yeah, like, there's this mysterious thing, the first thing you jump at is the mysterious magical thing that might happen, only to prove yourself like, now it was not running, it couldn't be that. So what could flip a bit? Hardware? That's the only closest thing that you can think about, right? So like, that doesn't make sense. Why would you, why would hardware like sit there, wait there for 1 week and then say like, yep, this bit flip. And it would be always at the same call stack. That just doesn't make sense. That doesn't happen. Well, we ran out of options. So maybe? So we asked the people, hey, is it by chance reproduced only on one machine? I was like, how did you know? Like, okay, now we're getting to something. So we actually ran, we took the machine out of the pool. Lovely, everything worked. And then you start asking like, so why was it always at the same call stack, right? Because it was probably some bad CPU, bad memory, probably bad memory if I would have guessed, right? There was some part of the memory that's here and there flipped bit because like it was unstable. I think that they even ran some memory checks and I think it failed. I don't remember honestly anymore. But like, why would it fail always at the same call stack? Doesn't make sense. Well, it's a really good question. We didn't find any good answer. So that was the first time I met magic in, in IT. I hope that you will not have to find it. I would love to say, so what I learned from this is that debugging hardware errors is really costly and it's really hard. I had my fun, 1 week of assembler. I asked my friend, like, dude, like, can you check this out? Because this doesn't make sense. Like, am I unwinding the stack correctly in my head and whatnot? It checked out. And I would love to say that I learned my lesson and I started asking every time when I see something mysterious, weird, and things like, does it reproduce only on one machine? Now I do that. If you meet me on GitHub, something weird and fishy happens, or or support case, whatever, first thing from me will be like, does it happen on one machine? And if you say yes, I'm not talking to you anymore. Because if it's one machine problem, it's super hard, super costly. I'm not gonna waste that time on something like that. I would love to say that I learned that after this. It took actually one more debugging of hardware problem for me to learn the lesson. And since then, honestly, something mysterious, no, don't investigate. Funny thing, when I talked with Maoni, who's our architect of GC, she actually told me that at certain time when cloud was not a thing and VMs were young, she actually owns the GC, right? The garbage collector, which is like very tricky and whatnot. Garbage collector was often failed, again, because it's magic, right? Often kind of blamed for things. And she even refused to investigate anything that happened on VMs. She said, basically, does it happen on real hardware? If not, I'm not investigating, because VMs were young and they did corrupt memory here and there. And that did, GC didn't like that, obviously, because if for the GC you corrupt the memory, it works with garbage, and garbage collector, well, doesn't work quite well. Anyway, so it's kind of interesting that, sometimes you want to isolate yourself from the stuff that's weird. So yeah, I always ask since then, does it happen on more than one machine? Actually, my second thing was that we even had a case that it happened on multiple machines, but it was exactly the same build of machines with exactly the same hardware, with exactly the same bad driver, which did happen here and there, corrupt memory. How do you find? You go, debug, you have your suspicion, you ask, can you run it on different, configuration? Works? Good. Everyone's problem solved. Let's not dig into chase down where's the trouble in the driver that you don't have usually source code for, right? So that was kind of metadata story, and I would like to tell you one more, which is interesting and I found useful and kind of compared to what I learned at college. So first I need to give you a little bit metadata background. What's metadata? Metadata is description of your program. So in .NET and Java has something similar, probably called metadata as well. When you basically say like, oh, I have classes, I have fields, there's some code, but there's just like it's somewhere out there, right? So you describe just like fields, methods, classes, interfaces, and these type of fun things. And in .NET, it was designed by people who designed databases. So it's actually basically a database. You have rows and you have columns, you have tables. So this is example of type def table, which is definition of types and interfaces, which has some like flags. Is it public, private, right? That it has type name. It doesn't have inside the table. It just has like, oh, type name starts at offset 27 in string heap, and string heap is a blob of characters. You say like, oh, well, you go offset 27. That's where starts name for this. So you can basically save if two things are same, called the same, they can point to the same string. But that's a teeny tiny thing. So you have index over there. You have index into the type namespace. What it extends, and you have the interesting thing, extends like which type it inherits from, which we're not going to go into. And as well, it has like method list, which means it says like, hey, my methods, I'm type foo, the first one, my methods start at offset 10 or number 10. And how do you find how many methods has type foo? Well, you look at the next one, which is bar, and it starts at 12. Therefore, you have number 10 and number 11. Simple, right? Easy. Type saving, we don't have lists, whatnot. Like, you have basically this kind of continuous list of methods, and it's chunks. One type, another type, another type, another type, in the order of types. Very simple. Now, Another fun thing, like, space was precious in those days, and it still is now these days because of internet, but it matters if you use 2 bytes or 4 bytes. So what do they do? If you have like, 27 types, why would you use 4 bytes for indexing types? You say like, no, there's less than 64K types. Let's use just 2 bytes. Pretty simple. You have some information at the start, how many of things you have. So golden, right? Now, sometimes types have 0 methods. So if type foo would have 0 methods, what would you do? You would say, hey, I start at method 10. And you would say like type var, I start at method 10 as well. So if you look at type foo, you would like, hey, method 10 until, oh, the next one is 10 as well. Oh, I have nothing. But what do you do? So we basically kind of do and actually, yeah, and if it's the last type def, so last type, what you need to reference is the number of methods plus 1, basically the one that doesn't exist. That's the only way how you express the last one doesn't have any methods. Now, what happens if you have exactly f methods? You add 1, that kind of, by the way, fits into 2 bytes, and you overflow into 4 bytes. Now, where's the problem? If you look at the spec, and there's a CLI ECMA spec that was used by many, you actually can look that basically says, there are 2 rules that says like, hey, it can be 2 bytes only if it's less than 2 to 16. It's not less or equal or less than 2 to 16 minus 1. It's exactly this, otherwise it's 4 bytes. And then you have another part of the spec that basically says, oh, you can reference up to row count plus 1. These 2 things don't go well if you're on the boundaries. And if you need to reference in the extreme case that something doesn't have anything, the row count plus 1. So how do you fix something like that, right? You don't. It took 17 years for somebody to report this bug. And basically look at that. Like you could go and fix that. But what happens? You would have to change all the compilers, and there's a dozen. All the debuggers, all the profilers, all the metadata readers and metadata writers, and it's like we're talking dozens. To orchestrate that in the community, in the environment, back then actually most of those things were open source or even some closed source, it would take roughly 10 years. So for 10 years, you would have half of the tools working on the old style and half of the tools on the new style, because you have to change the spec. You have to define, oh, if it's this special case, then we use 2 bytes or 4 bytes, or if it's 0, it can overflow, and there's options. But you basically have to change the spec, and changing spec is really hard. That's what they taught us at school, and I didn't quite understand what they mean. This is like an amazing example. But the nice thing is actually, if something happens once in 17 years, honestly, you will have to fix it. So we told the customer, you know what? Just add 1 more method, fake method or fake type. Don't make this one the last, whatever. Just insert something, it's gonna go away magically. And it did. And it's the cheapest thing, because coordinating like dozens of companies doing something for 10 years is just way too costly. So that's one kind of thing that came out of this, that you don't have to always fix all the bugs. The other things, actually, I was not owner of this anymore. I was already manager. I was like 5 or 7 years not working on something. And this is a great example. If you touch something, you're going to be haunted forever, especially if it's open source, right? Again, I see Anička smiling a lot because she sees it in SUSE as well, I assume, right? In Lexi. You touch something, you can be off, you don't like it anymore, you work on something else. Somebody in 10 or 20 years will knock on your door. Hey, do you remember this thing? Like, does it sound right? So 2 lessons learned, like, yeah, you're going to be haunted. And second, not all bugs have to be fixed, which was interesting for me. I was always this kind of the mathematician guy, like something is right or wrong. Like there's this great thing that, it ain't that bad. All right, breaking changes. That's another interesting set of things that actually even Anička, I think, mentioned in her talk a little bit. So it's interesting. When you find a bug in something, in kernel, or for Microsoft in Windows or in .NET, it takes you a while to convince yourself, hopefully, to convince yourself that you found a bug. You report it, and you wasted, if you're lucky, only a week. If you're not so lucky, probably months. That's typical, right? And if you invested so much time, you really want that thing fixed, because you want kind of some reward for your pain that you went through. You don't want somebody else to actually go through the same pain. Now, the other thing is, if you update your software, you don't want to be broken, right? You updated new kernel. You want everything just work, right? That's what Anička mentioned. That's why you pay the big money, like enterprises, because what do you mean it doesn't work anymore? It worked before. Why? I'm just updating kernel. It has to be fully compatible. Well, it's not. And these two things kind of don't work really play well, because the observation is actually from .NET, from some of the top minds over there and architects. One of them actually was studying at the school, Jan Kotas, that 10% of bug fixes have unintended side effects. And it doesn't matter how many code reviewers you put there. They can be the smartest people. 10% of things will do something, maybe in some weird corner case and whatnot, that you didn't anticipate and nobody noticed. You can put 5 people on code reviews, the best ones, not gonna help you. Now, most of those unintended things, nobody cares about. Nobody will ever see them, or once in 17 years like the before. But here and there, they bite, and they bite hard. And they will not bite your CI. They will bite in production when you roll out, and suddenly it's the leap second or something like that. Nobody anticipates that, right? You know. And we had an actually nice, very nice extreme case. We made something faster, which is normal. Like, you know, if I give you a new version of Linux and I tell you that it's like 10% faster, you're gonna be happy, right? Because that's costs, you're gonna pay less money. If I give you better .NET, you run your .NET, you're gonna be happy. Well, we made things fine, correctly working, something faster, and we broke a customer. The customer was not happy because they just updated stuff and things stopped working for them. They were pissed, kind of rightfully. Turns out it was actually their fault. So they actually relied on dependencies of initializers, of the class initializers, which is by spec undefined. They were not evil. They're not saying, oh, I'm going to do something. I'm going to rely on the dependency. They just had code that used that. There's no detection for that because it's probably some NP-hard problem or something like that, or incompleteness. And they just happen to depend on something is 0 or non-zero. We made something faster. We changed order probably of the initialization. Something ran faster, suddenly, boom, it was initialized. Oh, I always expected 0 here, or vice versa. I always expect value, and now there's 0. Boom, right? You know. So it took them a while, and they had to basically say, like, yeah, you know what? We screwed up. We relied on something that we didn't have to. We shouldn't, but we did. And there are 2 lessons from this. Actually, I didn't mention the second one, but first thing, like, everything you do, no matter how harmless, like making something faster, has risk of breaking somebody. Now, the good news, if you have your end application, there's nobody up on you. Maybe your customers, but you know, they will just report back to you, you're gonna fix it. If you're Linux kernel, if you're .NET, if you're Java, if you're something lower level, it bites. It bites your customers who are developers and their applications are broken. Even worse, if it's something like kernel, it just gets swapped, or .NET framework itself just gets swapped on the .NET, on the machine with next security patch and whatnot, and boom, applications, half of the bank is not working, right? You're not happy about that. So that's interesting that really everything, even making things faster, you can kind of have or whatever proof you want, how many you want, there's a risk that you're gonna break somebody. Now, in this case, what I liked that Microsoft is very practical, I believe every larger enterprise company is practical. If we saw there's a non-trivial amount of customers hitting the same thing, even though it's stupid, it's their fault, but if there's many, what do? You roll it back, or you fix it, you patch it, and you basically define the bad, old, slow, or whatever behavior as the right one, because it's not worth fixing it and breaking the world, or breaking 10%, or even 2% of your customers if you have a lot. That's a lot customers, right? However, if it's only one, sorry, go change your code, right? Honestly, my deal, which is actually related, when we have something on GitHub and people say, oh, we have this bug, and like, obviously it took some time to find out what it is, you should fix it, and networking and whatever. Sometimes when it's difficult and crazy and like weird, and actually it's kind of, actually the bug is that we're doing the right thing and before we were not, so we fixed something. My first thing is like, okay, how many people are heard. If it's less than 5 or 10 on GitHub, do I want to pay attention? And I bet that Linux kernel, the bar will be even higher or somewhere else. Anyway, another great and almost extreme breaking changes is the last build. So we had last build of Windows 8 on ARM. There was Surface RT, the great devices, that Microsoft pushed, and Finance App application, which was built in part of Windows, stopped crashing on the last build of Windows 8. Like literally the last build that you put and give it to OEMs like HP and Lenovo, they burn it into their devices and they sell it to the customers. So it's a big deal. It's not RTM, it's OEM, RTM, but it's a big deal. We found out that actually it was a lot latent bug that was there introduced already months ago. It was sitting there and waiting for the right moment, and the right moment started on the last build. And it needed basically engine images, which is pre-compiled because .NET is like JIT compiled like Java. You kind of save it into engine images. You kind of make a snapshot of that compilation, so you don't have to do it at startup again. And if something was aligned, across the 8 kilobyte pages, it triggered problem actually on ARM processors that was specific to ARM. And if GC happened twice on that call stack, then boom, it kind of got triggered. It's kind of weird combination. So you have to have some code online, and it has to be sitting basically for a long time. Turns out that one unlucky change moved constructor of default proxy information. Default proxy goes into networking and says like, hi, I want to know about my proxy. It takes forever from an application initialization perspective. So it's sitting there waiting for the result. You go to the network, we're talking at least milliseconds. It's forever basically. And that thing definitely in the up startup, you allocate like crazy. You kind of create this, so GC kicks in here and there, right? Well, it kicked in, it called this function twice on the call stack, and it just happened in the last build, some unrelated change somewhere pushed this thing on the 8K boundary. So the bug was there. There was something totally innocent, something saying like, oh, we're gonna add, we're gonna check instead of A as well for B, C. You can look at the code. It cannot break anything. Well, it can, because it can push something out and some other long existing bug will suddenly come to be fruitful. So that's an example of no matter what you do, you can always kind of break. All right, okay. Are we working? Okay. Sorry, I'm connecting. That's not healthy. Anything can break anything, right? So. Just a sec, we're trying to fix it. I'm gonna have to reconnect, I guess. Můžete sdílet All right, we're gonna have to start sharing from another computer. Sorry for that. We have backups. You touch the network, you break something, right? And I didn't touch it even. It touched itself or something. technical problems. You know what? In the meantime, I can go on while the guys over here fix it. And okay, cool. So let's jump through. All right, here we are, anything. So as I said, like even this kind of innocent thing, you know, could break something, which is again, a little bit surprising and makes you a little bit paranoid working on something like Linux kernel, Windows kernel, .NET framework, Java, anything lower level used by millions, if not billions. Well, and I have actually one last story about breaking changes, which is a fun one. So sometimes the breaking changes can have really big impact. There was one day a patch of .NET framework which broke certain, I cannot name it unfortunately, text software in US. It's a big deal. You know, turns out that software in US are mid-April, which actually, you know, start of April, end of May is usually most countries do their taxes. Mid-April sometimes can be the second Tuesday. Or very close to the second Tuesday, which is Patch Tuesday, when like security things are pushed. Not sure if only by Microsoft, maybe even like worldwide, but definitely by Microsoft. So we broke certain software. We broke printing text forms. Turns out lots of people still have to do their software text and then print it and send it out, or at least back then they did. And we pushed the update actually a few days before the deadline for the US tax. That's kind of pretty crappy, right? You know, so you do your taxes last minute. Everyone, you know, you probably don't earn enough money yet to do taxes, but most people like me do taxes last minute because it's fun and because you hate doing them and it's pain. And then you cannot print it and send it. So what was interesting that the printing of taxes or printing in .NET was tested by both Microsoft and even the text software company because both realized that it's important. But what we did, we tested print into file. You know, oh, you can see it. Yeah. We tested printing into file. We didn't test printing on printer because imagine you having your CI, right? You know, every 5 minutes there's a page going out, right? You check, yeah, yep, still good, right? You have a person sitting there. Now, there's a side note. I was giving this talk actually at a company, I think Vysoft in Brno, where I live. That's actually a company that they're working on printers and on even copy machines, and they have actually cameras and they have things touching the copy machine if it does in the menu what it should. So they are probably the people who really need to kind of, you know, really print something on the printer, but it's probably 1 or 2 companies in the world. The rest of us, normal people, we don't want CI kind of to print you things. Well, we broke that and we only broke it printing. So there was actually an interesting lesson that we as .NET Framework learned. We actually broke that text software twice. That we are cautious around certain dates, which if you think about that, it's not so surprising. Large companies like, you know, Amazon, retailers, right? You know, Alza in Czech Republic or nearby and whatever, wherever you live, there's something. These are extremely careful around certain days. Actually, I have a friend in Amazon. He told me like, you know, yep, November, sorry, we're stopped working for the year. I was like, what? Are you lazy? Like, no, we cannot push anything in production. Because that's when the companies make like, you know, I don't know, more than half, like 70% of their income is from that sale. So if you have outage for 1 hour, it's a really big deal. So you need to be extra cautious around some sensitive days in Amazon, again, you know, and some companies. You would not think that .NET Framework has to be cautious. The tax season is kind of like, yeah, you should think twice. So, and I bet that the same thing works for kernel patches and whatnot, right? So it was interesting. Sometimes breaking changes, and now we're gonna jump actually to .NET Core, to the open source, are below you. So I actually met a kind of fellow speaker from RavenDB. I think he's from Brazil. At conference a long time ago, and then he picked me like, you know, half a year, like, hey dude, like you just broke us. You're blue screening. I was like, we cannot blue screen. We're user mode. We're not kernel mode. We cannot blue screen Windows. Like Windows is already kind of done deal. You know, they don't do that. Like, no, you're blue screening. So we dug into that. Turns out actually that we used in GC prefetch virtual memory because it's a highly optimized thing, which is probably used only by us and maybe Java. So almost nobody uses that specific function, at least on Windows. And there was some kind of kernel memory bug again in there, which almost nobody noticed except us. So yes, we started blue screening because we used something that broke. Obviously, for the customers, it looked like, hey, .NET broke us. Suddenly, .NET is broken. It was, well, actually, they updated OS and .NET was not working, right? You know, so it was actually a bug in the update of the Windows. So it was actually fun. Now I'm going to switch topic a little bit to optimizations, which is interesting and story in my opinion. That once upon a time there was a service. Think something large in Microsoft, like I don't know, Teams, Office, Bing, whatever, like large surveys that everyone recognizes. And a friend of mine worked there, and he said that their architects had a very heated, like 5 architects, whatever. They had very heated discussion about like, oh, are we going to use list or array? Oh, this says like here instruction, there instruction, better complexity here, over there, all right? Heated discussion. You probably at college sometimes have those as well. Like, I'm right, like this is faster, this is better. Well, turns out that the data structure typically has like 3 to 5 items. Nobody cares. If one thing is something to click faster or slower. Like in 99% cases, it was like very small amount. Just like fixed array, whatever. Like that's it. We don't need anything else. The other thing is actually the service itself had 3 hops between machines. So there were like 3 servers. To serve the request of the user, you had to hop to 3 machines. You're losing milliseconds between that, even if you're in the same data center. One instruction, sub-microseconds. I can't even say that nanoseconds. It's just like something so small that will not help. If they have focused on something like can we change it to 2 hop between requests, that might have saved customers or make it visible for them. But spending time on optimizing something like list versus array when you don't know that it matters is just waste of time. And that's one lesson I would like you to walk out from here today. Let's avoid basically premature optimizations. Don't jump to optimizing unless you have proved that it matters. If you do that, I can guarantee you're gonna 90%, maybe 95% case waste your time. A lot of time that can be used elsewhere. You can fix bugs that actually help your customers or do something more meaningful with your life or start a new project, open source project or something like that. All right, we have 5 minutes only. And I have one last interesting story, which is a little bit long, so I'm gonna kind of fly through that. So a long time ago, we had actually, I forgot which year it was, but we had some researcher doing some ML models on Cosmos, which was, think cloud before Azure was a cloud public offering. So it was kind of like pool of machines. They were running ML models, and they basically came and told us, hey, seeing something weird. We're sending requests and we're getting wrong responses. So first thing, okay, does it happen on more than one machine? Yeah, it does. Like, okay, shoot, okay. That's not gonna work out. It was still only in one data center, but they were the only people. So we said like, yeah, okay, maybe we might have some buffer problems. So we added some logging, came to them a couple of months later. They said like, you know what? The repro is gone, in March. Like, yeah, we don't have, they upgraded the machines and suddenly things work. So like, what do? Like, we don't do nothing. But then in May, we got similar report from another team. And actually, to make it more interesting, in 2 weeks, there were like, I don't know, dozen teams knocking on our door, like something bad is happening. And I was like, okay, this is a problem. So we started digging into that, and all hands on deck. And actually, one of the teams, the first one, I believe, they had actually a small repro. So they basically said, if you run this executable, in 20 minutes, you're going to hit the problem. They hammered just Azure, actually real Azure blob storage back then. And they basically checked, they hammered with A and B, like let's request A and B, like in parallel or whatever. And sometimes they check, like, do I get results for A because it was static file versus B? And here and there, they would get, once in 20 minutes, wrong response. So like, good, we have small repro. I'm gonna jump over that very quickly. There's something called time travel debugging, which basically records execution of the program entirely, which is magic, positive magic. If you can catch bug under that, it will record every single instruction on every single thread, what it does. You can set breakpoints, like data breakpoints, like who wrote this value, and you can go back in time. Because imagine that somebody recorded every single thing that was executed. Magic. It slows down the execution of the program 10 times. It creates gigabyte files, maybe even for 1 minute. And but if you catch that, it's lifesaver because you're gonna track down who the heck wrote the wrong data. Because you usually get, oh, you wrote it, but why? Oh, because you read this, which was wrong. Why did you do that, right? And you go back and back and back. Now, if you have this, not 100% reproducible bugs, it's a lifesaver. If you ever have to do something like that, it's awesome. So we found the root cause, which was interesting, that there's something called HTTP pipelining. Before that, what's normal HTTP? That you send request to the server, you wait for the response, then you send next request on the same connection, wait for the response, because you want to keep the connection open. HTTP pipelining basically says, which is actually something that I have, like you send request, you get response, right? HTTP pipelining says, you know what, you don't have to wait for the response, because you know that the server gets first response, it's first gonna respond to, first request, it's gonna first respond to the first one, and then it will start processing the next one. So you can basically make a pipeline. You send first request, second request, and you expect right order of responses. So response 1, response 2. Awesome. Now, what happens if you have 3 requests and the system is under heavy load? And by heavy load, I mean that you're gonna start getting timers, like, hey, this request is taking too long, just cancel it. So if you already sent the 3 requests and the first one is canceled, what you do, you could drain the response and throw it away. But what you typically say, you know what, this is useless, throw away the connection, let's cancel as well request 2 and request 3, let's make them retry. Simple, easy, right? What happens if you get cancellation on request number 3? Well, you remove it from the queue and just mark the connection. Don't queue more things in here because it's gonna then be kind of broken. And you just process request 1 or response 1, response 2, and then you kind of kill the connection. Simple, easy. What happens if from overloaded system, whatever, request number 2 is canceled? Well, we did something very similar. We just remove it from the queue, mark the connection for don't touch it anymore, don't send more requests, and then just throw it away. But well, what happens? You get response 1, you give it to request 1, awesome. You get response 2 because it was already sent, and you give the response to request 3. What could go wrong? You said, for example, like, hey, is this stored in the cloud? Yes, it is. But it was response to something entirely different, right? What was worth, in multi-tenant, which means that your service serves multiple customers, you ask data, hey, give me all the data about whatever, my financial situation. And you get information from another request, which might be another company asking for their financial institution, situation. That's not good. Customers don't like it. That's data leakage. That's a big problem. That happened. We had like 10 customers screaming at us. It was just logs, but it was like, hey, so we're seeing these logs. They look like from another company. Like, we don't mind, but who sees our logs? We don't like that. So that's obviously a big problem. So it turns out actually that HTTP pipelining is not recommended even in the RFC. So even the RFC says there be dragons. That was probably added a little bit later. Nobody noticed. We implemented that. Boom, hit us in the face. So we disabled HTTP pipelining. It has a little bit problems with performance because obviously you take longer to take requests, but hey, you have things that actually work versus fast. I think sometimes being fast and wrong is much worse than being slow and correct, right? So we worked on the fix, we tried to repro, and after 4 hours it fails. Like, what the heck? We just fixed it, right? Before it was 1 minute repro. I kind of smalled it down. Exactly the same symptoms. Wrong response to the request. It was like, what's going on? So long story short, it was fun thing. It was sensitive to hours. I was actually back then in US. So between 8 and 5 p.m., it was reproducing. I was manager, so I was like telling everyone, calm down, my team is working on that. And in the evenings, I had nothing to do. It's like, oh, let's go do some coding. I felt like stupid person because I couldn't even run the repro. I couldn't hit the, like, what's going on? Everyone on my team can do that. I'm so stupid manager that I cannot even hit the repro. Turns out after 5 p.m., you were less likely to hit it because there was less load on the cloud and timing was a key thing, you know, on the network and on the cloud. So time travel tracing for 4 hours, like forget it. That would be petabytes maybe or something, I don't know. So we got suspicions about the buffer that I mentioned again. We actually added some logging and guess what? We found another, and that bug was 13 years old. I forgot to mention, you saw it on the slides. We found another bug, which was very different. It was basically bad buffer lifetime management, which means that you gave the buffer, I was like, hey, here's the request, or actually the response. And before you let somebody higher up to process it, you put it back in the pool. And if somebody checked it out, wrote another response on there, then the original consumer woke up, read the response, finally, they already read another request, response. So it was like, yep, exactly the same thing. So we found a trigger that like there was change in .NET 4.7.1, .NET framework that actually made it happen more often. We don't know why, because when you look at the code, there was always window of opportunity when it could happen. We made the window smaller, and somehow it started triggering that it happened more often. Like, what the heck is going on? But such is life. On top of that, did you ever hear the story like, I don't test, and when I do it in production? Don't do that, but that's exactly what we did. Because if you have something sensitive like this, like, you know, we wanted to validate, we actually wanted to find what caused that. Skype team back then, Skype, you know, rest in peace. They basically was calling survey. They said like, yeah, just give us new bits. We have like the fast rollout, 24 hours. We can tell you like, yeah, if there's more rejected calls and less. I was like, won't your customers mind? Like, nah, we have some percentage. You're in the line. Okay, cool. So we basically iterated with them to find out, does it rip or does it not, and did binary search to bisecting to kind of find it where it was. It was actually quite fun, thanks to Skype team back then. So I already talked about that. So we found as well similar code, similar bug on the receiving side and on the sending side. So we had bad buffer management on the request and as well on the response. Entirely different code in different layers because it's a messy code. You don't want to look at that. And but very similar problem. Turns out that actually it was introduced under my patronage of .NET performance team when we tried to make things faster. We made them faster and run. Anyway, the key question, and I'm gonna finish because I'm 5 minutes over. Why so many customers suddenly hit it at once? The only reason we found out potential is that there was like Spectre and Meltdown fixes in Linux kernel and in Windows kernel around that time. Which if you heard about that, basically CPUs were kind of using some side channels, whatnot, and what basically operating systems have to do when they kind of switched threads, they had to flush certain registers more often so that they don't leak information between threads because they could be different privilege processes, and actually somebody exploited that to extract information from that. It was like via JavaScript remotely, which was like mind-blowing. Anyway, so they changed timing. And the timing probably changed things and suddenly said like, yep, this kind of sitting bug, 3-5 years and the other 13 years, let's go, let's roll. So that was the only thing, or magic. So that's what I started before. That's the only explanation why suddenly out of the blue, things broke. And because I'm over, so lesson learned from that, sometimes weird coincidences happen. So there's kind of this kind of magic in IT. We have to live with that. We have to be aware of that. We should not blame every single bug on magic. That's not healthy, you know. I'm gonna just wrap up. So, you know what, we can actually skip that. What you learned, you know, always ask like, you know, does it happen on more than one machine? Because you don't want to debug hardware bugs. If something happens once in 17 years only, you know what, it's okay not to fix it. If you have a spec bug, like the metadata bug, it's hard to fix them, really, believe me. Anything has the risk of breaking you. You know, it can be innocent change, moving things around. Suddenly, latent bug comes to blooming, and you're gonna be hit hard. And things that I mentioned, like always, when you have a problem, always create a small repro. Because like if you have something small, you can debug it. You can work with it. You can find out, does it work here? Does it work there? Even if it's like once in a minute or whatnot, you can work with that. If you don't have a repro, it's like, hey, somebody failed, like I have a fix. Maybe it's gonna work. Let's see, you know. That's not healthy. And sometimes there's really just magic. So with that, thank you very much. I would like to recommend, ask you again, and for the last time, please fill our survey, how you like the talks, what you would like to hear in future. We have actually in November planned another session. Typically, sessions were in November because we have an update conference organized by Tomáš Herceg's company, and they bring pretty cool international speakers, and we snitch them here, we kind of steal them, and they're very happy to talk to students about things. They talk about cool things. We might do even something offline. So yeah, we're gonna have cool things waiting for you, and hopefully you're gonna find about that as well and join us again, and hopefully you enjoyed today. So thank you very much. If you're in here, do we have any questions? Okay, no questions on offline. So we're gonna wrap it up, stop recording. If you have questions in the room, feel free to come here. Speakers are still here, so we'll be happy to talk with you, and maybe some swags up there about from SUSE stickers. I suck and I didn't bring any .NET stickers next time. So thank you, folks.
Okay, so thank you and see you next time.